Hi, in today's video we will learn about Bayes' rule. First we will see the concept of probability theory, then we will look into what is joint probability, how to find out conditional probability from joint probability formula, and what do we mean by Bayes' rule, followed by one simple example. So let us start with probability theory review. Probability theory, where P of A is called as probability of certain event A when it is true. So when event is either true or false, its probability can be found out using P of A. Say for example, in a particular box, if there are 5 red balls and 6 black balls, if we draw out one ball from particular box, then drawing up a ball is called as event A. Now what is the probability that drawn ball is of red in color? Say for example, this box contains 1, 2, 3, 4 and 5 red balls, and in the same box there are 1, 2, 3, 4, 5 and 6 black balls. If there is an event A of drawing one ball out, what is the probability that this ball will be of color red? So that drawing one ball is my event A, and the probability that this event will lead into red color ball is called as P of A is equal to red. Now, how to calculate this red ball probability? So as you can see in this particular box, there are total 11 balls, and out of 11 balls there are 5 red balls and 6 black balls. So probability of drawing red ball out of this box is 5 by 11. Now what is the probability that drawing one ball is an event A such that that ball will be of black in color? So that probability will be 6 by 11, because there are in total 6 black balls and there are 11 balls given in a box. So 6 divided by 11 is nothing but probability of drawing one black ball out of a box. So this is called as N. N is nothing but an occurrence of particular ball in a box, and X is nothing but total number of balls in particular box. That is nothing but sample size of a given example X. One important thing that we should note here is that probability of ball of being red plus probability of a ball being black is equal to always 1. That is nothing but 5 by 11 plus 6 by 11 is equal to 11 by 11, which is equal to 1. So for any event, probability will be always range from 0 to 1, and summation of probability of event where there are different outcome of even event is always states to 1. So these are the basic concepts or basic fundas of probability theory. So we show that event is not happened with its probability of being 0. That denotes an event is definitely not going to happen, and probability of an event, if it is 1, that means it denotes event will definitely going to happen. And for any event A, if sample size is X and there are n particular number of times and instance is present in X, we denote probability of A is n divided by X. In order to understand joint probability, let us assume one example. So there is a box where there are 5 red balls and 6 black balls. Now I want to find out probability. What is probability if I draw 2 balls one after another? One ball will be red and another ball will be black. So I want to find out probability of ball being red and another ball being black. When we say it is joint probability, which is denoted by this comma, these events are happening without any order. That means irrespective of first ball is black and second ball is red, or first ball is red and second ball is black. So what did this basically mean is that let us assume A is an event of drawing one ball and B is another event that shows we are drawing another ball, that is again one ball. Let us assume first we draw a red ball and later on we draw a black ball. We can consider in reverse also that first ball is black and second ball is red. First understand this concept with the help of Venn diagram. These are the probability of ball being red, that is event A is going to true. And there is one more event B, that this ball is going to get black. Intersection part of this event states that we have drawn one ball from this set and one ball from this set. So in total there are how many balls? There are two balls. If first ball is a set of all red balls and second ball is a set of black balls, then these two balls will be one of the red type and another one will be of black type. So we simply say that probability of event A and event B, irrespective of their order, is probability of event A intersection probability of event B. Now what is another this formula, or it is this expansion of this joint probability? What is probability of being a ball red? That is event A. So event A states that red ball there are in total 5 out of 11. And what is the probability of drawing a ball which is of black type? So black balls are 6 and there are in total 11. So probability of drawing a black ball is 6 out of 11. That is perfectly okay. So we are having this particular set as 5 and here we have 6 by 11 and here we have 5 by 11. Now what is joint probability? So let us assume that first ball that we are drawing is already red. What is probability that second ball will be of black type? Now what this probability is called as conditional probability. Now what is the meaning of conditional probability is that towards the right hand side of bar, whatever is written is called as already happened event. So this probability would be read as probability of ball being black provided that or given that first ball drawn is already of red type. So this is nothing but B given A. In our notation, black is B and red is A. I would call it as B given A. Now, probability of being first ball is black. What is probability that second ball will be of red type? So this is also giving us the same probability that first ball drawn is black and second ball that is drawn will be of red type. And this would be written as A given B. So we can assume either case that first ball can be either of red type or it can be of black type. Anything you can consider. Let me consider this case that first probability is nothing but probability of drawing a black ball, that is nothing but P of B. So I must have what is probability of ball of being black, that is equal to 6 by 11. Now I know that this event is already happened. This event is already happened. I want to find what is probability of being A given B is already happened. So probability of ball being red given that first ball drawn is already black. So this is nothing but our conditional probability. So if already one black ball is drawn, what is probability that first say this ball will be of red type? So now if one ball which is of black type is drawn by this probability, it will be removed. Now my total of box will be 10. So it would be 5 out of 10. There is only probability 5 by 11 and probability of black ball, 5 by 10 into 6 by 11. So this would be 3 by 11. Now let us consider probability by using this formula. We want to find out what is the probability of ball being black provided that first ball is already red. So I will calculate it here provided B given A. Right? So in this case, we know that already A event has happened. So we must have a probability of A. In order to find that both of these balls are drawn at a one time. So here probability of A is nothing but initially there are 11 balls without any removal of a ball. So probability of ball being red is 5 by 11. Now one ball is removed. At this time this red ball is removed. So again we have in total 10 balls. Now what is the probability of ball being black? That is nothing but ball being black provided that one ball red is already drawn. So that probability will be 6 balls out of 10 balls. So in total this will be 6 by 10 into 5 by 11, which is again 3 by 11. So either in the case whether first ball is red and black and second ball is black or red respectively, we get both probability of both balls, one being red and another being black, is 3 by 11. So I would write joint probability. Probability of event A and event B is defined as intersection of event A and B, which is known as probability of event A given that event B is already happened into probability of event B, and this can be also extended as probability of event B given that event A is already happened into probability of event A. So this is our joint probability. Now this particular formula, either this one or this one, is called as product rule. Product rule states that joint probability can be found using conditional probability into probability of an event. Now let us look into sum rule or total probability distribution. If there is an event whose outcome can be of multiple type, we can find probability of that event as summation of probability of A comma B over some different values of B. That is also given as that this conditional probability can be substituted with its product rule. So this product rule states that A comma B is defined as A given B into B. So this probability of A comma B is expanded as probability of A given B into probability of B. Now event B can take different values, which is nothing but set B. So for each B we can write B is equal to small b, and this formula is called as sum rule. Similarly, to find out probability B using sum rule of A, we write probability of B is summation of probability of B comma A over different events of A. Now this B comma A can be written as P probability of event B provided that event A is already happened into probability of A. Now event A can take multiple values or multiple outcomes. That's why we have put summation over A, and value of A is assigned to small a. Let us understand this joint probability. There is one toy making shop which produces 25 defective parts in a lot of 1000 toys. So if there are in total 1000 toys which are produced by a company, 25 defective toys will be there. Now here we are drawing two random samples. which are selected for testing, and we are drawing these samples without replacement. That means if one sample is drawn from a particular lot, it will never be put inside bag if we are drawing another sample. So one sample is removed, it is out of this lot. And we have to calculate probability that both of these samples are defective. Now mind that A is drawing one sample which is of type defective, and event B is again one sample which is being type of defective. So what will happen? Either A happens first or B happens later, or B happens first and A happens later. Doesn't matter. We want probability that both these samples are defective. So that we have to calculate joint probability. So event A is event that first sample is defective, and event B, it is second sample is defective. Whether we draw first sample first or second sample first doesn't matter. That's why we have to take or calculate P of A comma B. Now what is P of A? That is probability of first sample being defective is 25 out of 1000. So P of A, 25 defective piece out of 1000 pieces is 25 divided by 1000, that is equal to 0.025. Probability of second sample being defective provided that first sample is already defective. Now if there are 1000 samples and we take out one, my total of defective pieces would be 999. And in total there are, if one defective piece is taken out, there will be in total 24 defective pieces. So probability of second sample being defective provided that first sample is already defective is 24 out of 999. So here we have written 24 out of 999. That is P of B given A is 24 by 999, approximately 0.024. So joint probability is given as P of B given A into P of A, which is 0.025 into 0.024 is 0.006. So final probability of both samples being defective is 0.006. Now let us understand conditional probability and how to find conditional probability for Bayes theorem. We know that A given B is called as conditional probability, that event A is happening provided that event B is already happened. So as I said, towards the right hand side of bar, event is already happened, and this towards the left hand side event is the event which is going to get happen. We know by A comma B is equal to probability of B given A into P of A. And we already know that P of B given A is P of A given B into P of B. Now, even the in-joint probability order is not fixed. So, P of A comma B is equal to P of B comma A. I can equate both of these sides. That is probability of A given B into probability of B is equal to probability of B given A into probability of A. Now here what we can do is I can take A given B over this side, I can keep it over this side, and I will write it as probability of B given A into probability of A. This particular will go into denominator part, that is probability of A. Now this is nothing but our Bayes rule. Let us understand that Bayes rule by this derivation. So this is my joint probability. Joint probability is substituted by a product rule. Now this product rule we have already seen how it happens. And if there are different outcomes of event A and different outcomes of event B, complete conditional probability is given as substituting outcomes in each of event. That is, formula is kept the same in Bayes rule, but each event may have different outcomes. That is, A is equal to A and B is equal to B. Now, what is this marginal probability? Marginal probability can be calculated from different outcomes of A And here we have replaced this particular formula using something called as sum rule that we have already seen. So this is nothing but substitution of sum rule. If this formula is being too difficult for you, let us understand this formula with the help of one simple example. So here we have different emails, and there is a system which identifies email whether it is spam or not spam based on its subject. We are assuming that if subject line contains spam, so probability of mail being spam if subject is bulk. So that probability is 80%. If probability of false alarm is 10% and probability of receiving spam mail is 0.4. Now we have to find out that if any new mail is received with subject which is specifying it as bulk, what is the probability that this mail is being spam? So in order to understand this particular problem, there are basically three values given. First value is called as probability of receiving spam mails. So here let us understand by Bayes theorem. Event A is nothing specifying that mail is spam or not spam. So my complete mail area is divided into two parts. We can solve this particular value or this particular example in two parts. So I will be explaining you second type of method over the right hand side. So you can either use this type of method or this type of method. So as you can see, this complete square is of all mails. So mail can be either of type spam or it can be of type not spam. Now area which is covered by spam mail is 0.4% and rest 99.6% area is of not spam mail type. This is for distribution of event A. So I can write mail can be of spam type or it can be of not spam type. From value I can see that it is of 0.4 type, 0.4%, and so no not spam will be of 99.6% of mails will be of not spam type. So this distribution is over. Now let us find out another event. Another event, event B here is whether subject is specified bulk or not. So event can happen, either it can be true or it cannot be true. That means within a subject line there can be word bulk or there cannot be word bulk. So if there is a subject bulk, if there is a word bulk in a subject line, I would say B is equal to 1. And if bulk is not specified in subject line, I would say B is equal to 0. So we have now two different probabilities with the bulk. So probability that mail being spam with subject is bulk is 80%. So here we are sure that mail is spam and its subject is bulk. There are in total 80% of mails there. So if I write there are mail which are of type spam and not spam, this will be of 4%, 0.4%, and this will be of 99.6%. Out of this spam, if subject is bulk, these many mails are having 80% share. So if mail is spam and it is not containing word bulk, how many percent will be there? There will be only 20% mails. And another value is given as probability of false alarm. That means false alarm means mail is not spam but still it contains bulk. There are 10% of these kind of mails and they will be flagged as spam by our email spam filter. And what will be probability of mail which is of not spam type and doesn't contains a bulk is 90% of remaining mails. So probability of false alarm. So this is the area of not spam type and this is 10% of this 99.6%, and this is 80% of 0.4%. Okay, so we have to calculate now probability. What is new mail which is having subject as bulk? What is probability? It would be of type spam. So A is equal to 1 is nothing but spam mail. So spam mail's probability is 0.4%, that is 0.004. Therefore P of A is equal to 0, that is not spam, is 1 minus 0.004, which is 0.996. Now probability of mail having subject bulk, provided that it is spam, that is probability subject is bulk, given that mail is already spam, is 0.8. This is nothing but 80%. So probability of mail containing subject bulk but it is not spam is given as 0.1. That is nothing but 10%. That is this particular part. Now, what is probability that given mail is having bulk, subject bulk, and is also spam? So, probability mail being really spam provided that subject is already bulk. So, probability of mail being spam is equal to A is equal to 1. Given that subject is already bulk, that is B is equal to 1. So A is equal to 1, given that B is equal to 1 is given as probability of B is 1 and A is 1. That is, we are interchanging these values into P of A. So always left hand side, whatever towards the left of bar is always going to get upside. And here at the down we will have probability of B is equal. Now this probability of B is nothing but probability of being spam. Now spams are nothing but this shaded region. I need to find out this shaded region. So this shaded region is summation of this shaded region plus this shaded region. So this is 0.044. This is 0.004. This will be 0.0996. Okay, so this would be written as probability of B given A. B is equal to 1, A is equal to 1 into A is equal to 1 plus B is equal to 1 into A is equal to 0 into A is equal to 0. So this is equal to 80% into 0.4%, that is my denominator, divided by 80% into 0.4% plus 10% into 99.6%. So as you can see, 80% into 0.04% plus 10% into 99.6%. So out of complete area, this value would be calculated. This value turns out to be 0.031. That means there is approximately 3.1% chance is that if there any email comes in whose subject is bulk, being spam. So that is all for today. Thank you everyone for watching this video. This is Munira Topia signing out.